All right. Thank you, folks, to the committee and tech committee and everybody here for the opportunity to talk to you guys today about our work in Lake Ontario. When Chris and Aaron and Mike said, every year doesn't have to be a state of the lake talk. You don't have to just go through the objectives and put another point on the graph. Kind of looked at him and said, really? I can do other stuff? He's like, absolutely. I'm like, all right, then that's what we're going to do. So today, instead of talking just about Preyfish stocks, we're going to talk about the surveys that we use to make inference on them. Part of the reasoning for this is simply because the history of our surveys have actually kind of taken a lot of changes recently, and so have the faces in the room. There's a lot of new people, there's a lot of less people in some of our offices, but there's a lot of new folks, and I think it's a good opportunity to talk about how we've gone through the process of adapting our surveys to provide better information. A couple of things like testing long-held assumptions, figuring out how to improve on those aspects of decision-making, providing information for decision-making and adapting, and then what the impact of those survey changes have been, not just on our understanding of Preyfish, but also on what decision makers are having to deal with. And this is not going to cover all aspects of it. It's just going to cover a couple pieces. I first want to sort of acknowledge a bunch of folks that have been inspirational and educational for me in my survey, understanding how to really count fish. And one in particular is the time I got to spend learning from folks at the long-term ecological research site in northern Wisconsin, the North Temperate Lakes. And what I saw there was a really set a different view of long-term research. It wasn't, oh my God, we got to keep everything exactly the same. It was, we need to figure out how we need to change surveys to learn more about the processes that we're interested in. Some stayed the same, but surveys often changed. And that was really kind of transformational in what I came to the Great Lakes and started working. And when we think about the original sort of collaborative long-term trawl surveys that our office and what it was then and the state was in, they're really based on the 1960s and 70s understanding of the Great Lakes, not just Lake Ontario, but also Michigan and Huron. That's where the folks came from. They established sort of 5 surveys then, and the timing of them varied. Alewife was done in the April because they were very catchable to the trawl survey then. They assumed rainbow smelt wouldn't be, so they came back and did a whole other survey in May and June. Juvenile lake trout were going out in the spring, but they needed another trawl survey in July to figure out how early survival of those fish was working. There was a yellow perch and juvenile fishes. It has about 17 different names. It drives the database folks crazy. Done in the Eastern Basin for a long time. And then there was a slimy sculpin survey done in October. These have basically had these boats kind of working at all times for different surveys and really created a difficult environment to kind of change and do anything else. Where we're at now is we have one spring April preyfish survey that is targeted towards pelagic preyfishes, primarily alewife, but other native fishes and species listed in the fish community objectives, and then a benthic or fall preyfish survey that assesses those different communities. Many of those species are actually more accessible and have a higher catchability in the fall. But even that survey now is we're looking at it and asking, do we need annual information on these individual populations, or could we use every other year? Instead of having dedicated surveys for fishes of like sort of restoration and conservation interests, all of them are listed in our survey SOPs as for what we're looking for. And the surveys are sometimes, it's expensive to get the big boats and crews out there, but to add an extra half a day here to get, say, abatement samples that inform lake whitefish trends, that's where we get the value added efficiencies of these surveys. If there's time at the end, hopefully I'll get to go through some of the new surveys that we're experimenting with. So a couple different ways we've improved, and these are just sort of like high-level syntheses, what they were in the black and what they've become in the red. So most of the surveys, or all of them, were US only. We're now whole lake. They were specific depths. We now try to trawl every habitat that we can get our boat into in proportion to its availability in the lake. CPUE We want to use area swept. We want to use biomass and density so we can compare results to your lakes, other lakes, so we can fuel ecosystem mass balance models. You have to use the unit that's more transferable. Move away from sort of a single biologist model. We formed the first Preyfish working group in Lake Ontario in 2012. Try not to use sort of siloed data management practices. Try to be collaborative and share it. And then worked a lot with electronic data entry on all our vessels so we could really speed up our data reporting, data sharing and reporting process, because the decision makers need the information in August to make decisions in September or October. So if we would have waited till March, we'd be giving them provisional data, do not cite. USGS loves when we do that stuff. So we had to flip our entire process to make sure what we could be providing was in the right time frame. And then this last one, we assumed the history of the survey and the rationales were correct, but we didn't test those half the time because we didn't have the data shareable ability to test those. Now it's like, survey assumptions are great, but bring your data, we're going to test it. So for instance, in 1970s, as I mentioned, they assumed rainbow smelt couldn't be quantified in the April survey because of course they would be in the tributary spawning. Makes sense from a life history perspective, but when we actually put the data together and graphed it and even added the acoustics, we saw incredibly tight correspondence, highly correlated data series for a fish that is about at anywhere from 3 to 5% of our fish community biomass, and we're not making active decisions on it. So by ending that survey, we all of a sudden got twice the effort we could now spend, and that's what allowed us to shift to whole lake sampling. Similarly, our Preyfish surveys in 2010 suggested the Lake Ontario alewife population was crashing. This is the figure that got showed in this meeting in 2011. That number there was what had people worried. Everyone said, look, alewife are cyclic. They're always bouncing up and down in Lake Ontario, but they could be crashing. What was kind of weird about this was folks like Connerton and Yule would then get up and say, fisheries actually doing great for salmon and trout and their size is up. It's not the most consistent sort of predator-prey results. At the same time, I was trying to balance, I wasn't working on alewife then, an ecosystem model with Tom Stewart, and we couldn't balance it because of the inaccuracies of our alewife, because they're such a dominant part of the food web. So this is sort of the background and pieces that got us thinking, what are these assumptions we're making? One of them was we had to change trawls due to dracaenid mussels in 97. That's a head-on view of sort of the old Yankee trawl, about a meter high off the ground. Caught a lot of mussels. Bios didn't like that. Needed to switch. We switched to a more modern 3-in-1 trawl, about 3 times the headline height and little foot rope space to not catch as many mussels. Did their due diligence, did 100 paired toes. The new trawl caught at the same site, at the same time, 2 to 3 times the number of alewife. Tells you a little bit something about the behavior of the alewife when we're sweeping through them. We were likely losing 2 to 3 times of the alewife over that head rope. But because they had, whatever at the time, 30 some years of old data, they chose to convert the new data point back to the old data point to keep the time series consistent. But that meant reducing new trawl catches by 72% when they were out deep. The problem is all the fish were shifting out deep. So here's 2 graphs that illustrate what the catches look like before the correction in density of alewife and what the catches look like after the correction. Not only were we simply overcorrecting or correcting to a different standard, we were actually introducing the trend that was causing everyone to freak out about the status of the alewife population. It wasn't real. We were inputting it into our analyses and our assumptions, right? So we were like essentially creating that crash. So, right, so there, yeah, 72%. So the other assumption was that from old to even in 2010, we assumed the numbers of alewife a catch in the US are indicative of the numbers you caught in Canada. Probably seems like a reasonable assumption. Today, this is the difference. This is what that same survey looks like today. Whole lake coverage everywhere. If there's a spot in the lake we can get the boat safely, we drag the nets, including any of the embayments. When we go out into and actually looked at those first years, the first years we did whole lake sampling, we had estimates of alewife in Canadian waters that were 90 kilograms per hectare. At the same time, they were 30 kilograms per hectare in the US. Oh, we were missing something. Then we go back out the next year and the trend is almost the exact opposite. And then it goes back again, right? So all of a sudden, we realize not only is this whole lake sampling and whole lake survey approach that we've adapted to important, it's fundamentally changing how we think the lake ecosystem and the fish population is working. It's not always different. Some years it's the same. First thing I usually want to talk to the anglers, they're like, why is that? I'm like, I don't know. You tell me, because honestly, we don't know right now. We're working on it. We're trying to figure it out. We don't have quite enough years to run enough analyses, but it's important. It happened again in 2025, where Canadian catches were just that much, at least twice as high as they were in US waters. Since the lake's approximately 50-50, the actual, more accurate biomass trend is a lot smoother, right? It's not up and down. I remember, I don't think he's here, but I remember when Dr. Hondort once said, looking at a graph, BW, fish populations don't go like that. That's not how they worked. And it's like, right, we're thinking too much that the survey represents the population. The survey represents a sample of the population, not necessarily true. So the alewife population probably doesn't fluctuate as much as we think. Work a lot on craignines and have been rereading a bunch of literature. Betsy Baldwin did a really neat assessment of everybody's opinions in Lake Ontario on the potential to reestablish bloater. 6 different Lake Ontario biologists agree, Canadian and US, that current pelagic fish of the smelt are well known for their population fluctuations. It just cracked me up to see all the initials of people behind there, because I don't think those individuals ever agreed on anything else all unanimously. But it's like that was the conceptual model baked into everybody's ideas. But now we know that that was actually mostly a survey bias, right? Other elements of sort of Lake Ontario alewife lore or dogma, as I call it. Well, it's all cold winters. They drive the mortality events. Actually, it looks like now density is that primary driver. Yes, cold winters exacerbate it, but you have incredibly high mortality events like we had last year when you have incredibly high densities. It fits a little better. Age 1 alewife don't fully recruit to the gear. It's because they were in Canada. There tends to be a higher density of the younger fish in the Canadian waters. We weren't towing, so all of a sudden, it looks like, oh, they're actually fully recruiting to the gear when they're larger. They were fully recruited. We just were missing them. So now we actually have accurate survival estimates. Our survival estimates straight from our survey are below 1. Kind of cool. The fish don't magically double in size from one year to the next or double in population size. So we can predict the population. So for any year, we understand where the current biomass is. If we understand just a distribution of survival estimates and a distribution of growth estimates, easy math, we can predict the population. Yes, there's wild error bars on this because nothing's filtered out. We still know there's plenty of warts in there, but we're not taking them out on purpose because we tend to be pretty accurate with where we predict. This shows the error. This shows the sort of where we predicted and where the observation landed. And so making these changes has dramatically improved the decision-making process to not be so reactive. They're not worried about the populations fluctuating. And so they can set more sort of, I won't call them standardized rules, but these guys are working on series of indicators that they can then communicate to the stakeholders when and how they'll make decisions. And it's based partly, at least, on this alewife biomass number. I mentioned that mortality event. This doesn't account for that. So that prediction could be way off this year, but it's unlikely to be based on what we've seen in past years. I talked about these things for native fish restorations. This is just a map of where a bunch of the trawl surveys are. This is the map of where we've been catching wild, reproduced lake trout, right? The species of restoration effort over the past 4 to 5 decades. We always talked about this area down here, but in reality, the Bay of Quinte is just as hot. The Adolphus Reach area is just as hot for producing wild recruits. You're going to hear more about that later. But this survey is meant to inform those processes. So we've tried to be more efficient. We've tried to cancel things specifically so we can think about the surveys we need for the next 30 years. And Dr. Fitzpatrick, in her very full analysis of the predator-prey relationships in Lake Ontario, boiled it down to the natural Chinook salmon recruitment has the greatest influence on the future of the alewife population. If it can be quantified, not only is future salmon abundance understood, but you have a better idea of how to balance predator-prey. So a group of good-looking individuals have been going after this idea of how can we create a survey that estimates the density of age 0 Chinook salmon, figures out their source, are they stocked in wild. We want it to be after major survival filters, but before stocking decisions are made. We worked a lot. We read everything we could on like the work of Jim Johnson from Northern Huron, but we also turned to Dr. Beamish's work out in the Pacific Northwest to understand how they trawl and estimate Chinook salmon in their wild habitats in the ocean. They trawl, which I'm kind of good with. I like that. So we started bottom trawling at night and fast, and we can now catch on the order of dozens, almost 100 this year, age 0 Chinook salmon. The length frequency of them is kind of interesting, a little bimodal. If we assume that that's a naturally reproduced fish, which tends to have that slower growth initially, that's a stocked fish, which tends to be larger, assumptions that we are following up and checking with parentage-based tagging as well as otolith microstructure, we can create the first estimates of age 0 Chinook density. These are U.S. waters only. We often talk about, people get sick of me talking about how percentages can lie, right? A percentage of wild fish, if you change in stock fish, can change your wild fish. You need to just know the actual density of these species. But, all right, are we close? Let's assume there's 1 million or so Chinook put out in these 2 years in the U.S. waters, a modest survival estimate of 14%. You estimate 140, 170,000 age 0 stocked Chinook. At least we're on the graph, right? We know there's probably more to do with this, but we're close. So we think we have something. The other thing is this survey is specifically designed to also provide age 0 Corriganine density estimates. All right, take-home messages or soapbox. You can pick which one. Sometimes I think we think the survey results are too much of truth, right? We need to actively test those assumptions. It's hard to get better if we resist change, right? It's hard to change, but that's a place where we learn a lot. The processes that we've gone through have been guided by first, the information needs, which those change, meaning we're going to have to change. Then sort of our way, how accurate we are at population, and then history. We're not forgetting it. We're just not putting it at the front of the line. The efficiencies allow us to actively evaluate new possible surveys. I underline that because you do a survey and then your vessel crew is like, we're doing it again next year. Maybe. That's a discussion, right? That's a piece that we argue back and forth about. We might want to try something different. We don't want to get stuck in the next thing as we're trying to figure out what we do for the next 30 years. And when we think about these considerations for new surveys, we're thinking about decision maker uncertainty, early life stages, and spawning habitat. I see my time is pretty close, but with that, I'll take any questions. Thank you.